Right, just before we go, I want to talk about the way that we think of angles, right? So chances are that if you ever speak to another human being about angles, we are used to talk about things like in degrees, right? So degrees is kind of these things that we were forced to use. We learn about, it starts at 0, we go, the diagonal is like 45, and then a right triangle is 90 degrees, and then you go into 180, and the full rotation is 360. So the degrees is this classic thing, right, that between human beings, it's easy for us to kind of visualize. We are used to think about degrees, angles in degrees, going from 0 to 360, and then rotations starting back up again. But the issue is we do not, the computer graphics and the computer graphics frameworks and the computer graphics libraries that we use, and even programming language built-in functions, they don't like computing things using the unit of degrees. We're going to use a different unit. And if you ever remember from your scientific calculator, we had degrees, and we have something called radians, right? If you remember from your Gaxio scientific calculator. So what are radians, and how do we reason about these things, and what do they actually mean for us? Nice. Given that we have, think about this rotation unit right here, right? I can start here and I start rotating back to 360 degrees. What is a radian? How can I visualize a radian in this point? Let's say that I have this rotation unit has a radius here, right? So I have this side right here with my radius. The reasoning about things is, if I come and I get this length of the radius and I project to the same length that I have on the radius, if I travel the same length on my arc, so if I kind of just project this thing to my arc, these are the same length. So the arc length is equal to the radius. If I travel this much radius here, the angle that is formed here is 1 radian. So that is how 1 radian is explained, right? This is what 1 radian is. If I travel 1 radius, this angle right here is going to be 1 radian. This also, if we extrapolate this idea, if we think about 2 radians, is going to kind of be around here, right? If we go 3 radians, is going to be right there. So 3 radians is there. So what is the equivalent of our 180 there? Well, it's approximately 3.141592 radians. That means that 180 degrees, the equivalent of kind of this half rotation is pi. So I go pi, if I go half, and then the full rotation back here is going to be 2 pi. So instead of going from 0 to 360, my radians measurement goes from 0 to pi and then back to 2 pi, 6.28 something, right? So 0 to 3.14, back to 6.28 something. And you will see whenever, if we are if we are printing the value of the, if you are consoling, logging out the value of the angle in radians in our JavaScript or in C, you will see that the values are always in radians. They will be, for example, 1.5, and then 2.68, and then also 6.28, and then back to 0. We'll always be talking about radians. So instead of using 0 from 360, radians go from 0 to 2 pi, right? Don't worry, the chances are that if I am going to speak to you about angles, if I want you to visualize or reason about an angle, chances are that I'm still going to talk to you in degrees, right? Because it's easier for us as human beings to visualize things in degrees. I don't ever remember anyone kind of talking about a skateboard maneuver saying, oh, he did a radical 2 pi maneuver, right? It's always like 360. That's how we think and we communicate with each other about angles. But now that we know that 0 is 0, 180 is pi, and 360 is equivalent to 2 pi in radians, we can kind of reach out this simple conversion formulas, right? So if to get an angle in radians, given that I have an angle, the value in degrees, all I have to do is multiply the angle in degrees by pi divided by 180. This is the formula for converting degrees unit to radians unit. Quick, simple, if we look at the code, and this code is present in most of the computer graphics libraries, we're going to have things that convert from degrees to radians and returning a floating point, a double for us, right? So degrees to radians, I receive degrees as parameters, and I multiply that parameter by my constant pi, 3.14159, divided by 180. Simple function. We might actually write this function and use it later. We can write it manually and have it in our source code repository. So we might going to need to use this conversion here, and the opposite as well, right? So doing some quick algebra here, what is the equivalent opposite? To, if I have an angle in radians, if I want to get the value back to degrees, I say the radians is times 180 divided by pi. If I perform this, again, the same idea. Radians to degrees, if I receive 1 radian as parameter, is the return of that parameter in radians times 180 divided by my constant pi. Very good. So we do have these two conversion formulas here. Don't worry about remembering these things. We can quickly get to these formulas by saying, okay, 180 is pi and 360 is 2 pi. We can basically just infer this formula, right? Just by thinking about the relationship between things and what is equivalent to what. Let's say another example, right? Let's say that I have my player and I have my field of view, again, of 60 degrees, and my projection plane of 320 columns, 320 pixels there. If I cast a ray to the first column, how much do I have to increase the angle to get to my second ray? So how much is the increment that I have? What is the slice? How many times do I have to slice my 60 degrees to get to my second ray? So given the dimension of my projection plane is 320 by 200 and my field of view is 60 degrees, the distance between each one of those rays in angles is the 60 degrees divided by how many columns I have, 320, right? That will give me how many slices do I would divide everything in several 320 slices because I need 1 slice per column. So I divide by 660 degrees and I get how much do I have to increase my angle each one of the slides. Looking at the code right here, I think it's easier. We're going to have a constant in our code that is going to I'm going to call it the field of view angle, which is going to be 60 degrees. But I have to convert to radians, right? This FOV angle will store things in radians units. So 60 times math.pi divided by 180, right? Math.pi is the constant pi divided by 180. 60 times math.pi by 180 is the equivalent of 60 degrees in radians. Good stuff. I also have how many rays I'm going to have, because how many rays I'm going to have means how many columns I'm going to have. That is equal to 320, which is equivalent of how many columns I have in my projection plane. Let's say that I declare these two constants, and then right there in the middle of my code, in the meteor part of my code, let's say that I have to calculate. I have an angle of a ray, and I have to calculate how much do I have to increment to get to the next, right, to the one on the right. All I have to do is ray angle plus equal, so I increment what I had before by field of angle, which is my 60 degrees in radians, divided by the number of rays, 320. So this will give me the little slice of angle that I have to increment my ray to get to the one in the right. So I increment ray angle plus ray angle plus ray angle plus ray angle plus ray angle to get to all these rays that I have to cast and complete my 320 unique columns of the resolution. Guys, just quickly speaking about the idea of degrees and radians that we are touching here, you will see that computer software, right, user interfaces, they will ask you to, sometimes if you are talking about the user interface, they will talk and get input from the user using degrees. Because it's easier for an architect, it's easier for a game level designer to think about what is the rotation of the character in the game in angles, But whenever in the back end, right, under the hood, whenever we are storing that value, we have to go and convert from the degrees that was in the user interface to radians. So we do our calculations in radians in our code, and whenever we have to do, save it in the database. But whenever we are, again, if we have to expose that thing back in the text box of the user interface, we convert back to degrees, and then we expose the friendlier version for the user, right? The human being that we're trying to communicate. So always keep in mind that if you're talking to another human beings, you will talk about degrees, but you have an equivalent value in radians, which was what computers kind of like working with. All these things that we spoke over here are going to be useful for us to start thinking about casting arrays, getting the distance from the wall heat, and etc. So right now, I want to stop talking too much. I want to go and start, and let's start thinking about drawing our map. Let's think how we're going to represent our map using a class, an object, how we're going to represent all these different walls in our game scene. And then also think about how we can have a little player object and we can navigate using the arrow keys. So we can go up, rotate, right or left, and kind of go and start creating the little boilerplate, the genesis of our code using JavaScript, which is the language that we're going to use. Stick around. Talk to you soon.